lecture from the PALFINGER AG. Well, the title is Everything Energized, Challenges and Opportunities of Electrically Powered Bodies and Lifting Solutions. I think some special applications you're very experienced in. So the floor is yours, please.
Thank you. So good afternoon from my side. I'm happy to kind of close the day and give you an overview about the electrification strategy we follow at PALFINGER. Yep. My name is Andreas Hille. I'm responsible for the Global Product Line Management Engineering. It's the organization where we have combined all engineering activities and all product management activities at PALFINGER. PALFINGER is a market leader in mobile lifting solutions. We are, 2021, we generated 1.84 billion of revenue. We have 30 production sites in, and 5,000 service stations, 12,000 employees. And we are mainly focused in, of course, in EMEA. This is our core market, but we're also heavily growing in North America, in Latin America, and APAC. We actually provide lifting solutions in two main applications, two main segments. On the land side, where we are providing loader cranes, access platforms, timber recycling cranes, truck-mounted forklifts, hook and skip loaders, tail and passenger lifts, so all kinds of lifting solutions which are mounted on trucks. And on the marine side, we are focusing on offshore cranes, on wind cranes, marine cranes, but as well as any kind of deck handling equipment, davits and safety boats. So it's quite a portfolio which we are providing to our customers. And of course, the topic about electrification is key. As a company, we are founded as a mechanical engineering company, but what we actually do is that we are transforming into a technology company, mainly because of the kind of changes we have in our environment. Digitalization and electrification really requires to build up new capabilities for a company which is mainly based on steel and hydraulics. And now we suddenly get new requirements on the electrical side, but also on the digital side. When we look at our products, we provide really tools which are multi-use. So it's kind of the Swiss Army knife with a PALFINGER loader crane. You can do many things and can use it in many different industries. So from construction to railway, all the way to the marine industry, the classical loader crane, but then also timber and recycling, oil and gas, and all different kind of applications you can use the equipment. Our strategy, of course, is based on really, the mega trends we are all following. Of course, sustainability is a key topic to make our products more and the world we live in more sustainable. Digitalization, of course, is affecting us, and of course, social change. The availability of trained people and resources is really critical, and all this goes into our strategy. But of course, short-term effects like the geopolitical situation, inflation, supply chain issues, and pandemic is affecting us, and I'm sure you all have experienced this in the past years as well. Our strategy really is based on two main pillars. Number one, it's go for solution. And number two, go digital. Go for solution means that we are providing complete integrated solutions. So it's not just the crane, it's the crane integrated with the vehicle and all accessories and a lot of digital services where the solution is embedding into our ecosystem of our customer. So it's really all formed together in an integrated smart lifting solution. Crane is integrated into the vehicle and embedded into the ecosystem of our customer. Important is that a smart lifting solution is also an eco-efficient solution. So the topic about electrification is really kind of key in regards to solution, but also in the area of digitalization. because at the end, it's really an eco-efficient solution is then a smart solution. When we talk about eco-efficiency, we have identified kind of 4 key levers we have to look at and need to understand to really create a system which is much more eco-efficient as before. Number 1, it's of course the energy supply and the energy efficiency in our core lifting solution. So how much energy are we actually using to perform a specific lifting job? On the other side, what type of energy is available for us? Because that's really the big change now. Moving from kind of a mechanical type energy to an electrical energy is changing everything for us, looking at our lifting system. It's also, number 3, how effective the lifting solution, the lifting work is. How effective is the work of lifting something? How repetitive is the work? How many mistakes I can make? Because all this is also consuming energy. And then, of course, our lifting systems need to be transported to the place where they perform the lifting job. So, of course, the efficiency of the vehicle also has a big part of the total energy consumption of a complete solution. When we look at the energy efficiency of our lifting system specifically, here's an overview of a classical timber crane application where we have a central hydraulic system which is driven by a mechanical combustion engine, mechanical PTO. So we really convert chemical energy into mechanical energy into hydraulic energy, and then at the end the hydraulics converts that into potential and kinetic energy. So we are moving heavy goods, we accelerate and decelerate, but we're lifting it to a different location, so it creates potential energy. And when we look into this energy balance of such a system, and the boundary conditions is you have a truck idling, engine running on idle, and you perform the lifting job. This is the condition. Interesting is that 100% of the energy we are using, 51% is created or transformed into heat, goes out on the exhaust system and the cooling system. 29% are the other auxiliaries like generator, air compressor, and other things which are also driven by the combustion engine. 5% is lost at the power takeoff, and only 15% is at the end used for our crane application, for the lifting job of the lifting system. 15%. If we take now those 15%, 13% are losses on the hydraulic system, on different parts, on the pump, on the pipes, on the tank, on the control valve. Only 2% of the total energy is at the end used as a change in potential energy, and the rest is all losses. But 51% is the engine. We can, by optimizing our lifting system, the area we can really optimize is only 15%. So the conclusion is we can, of course, focus a lot on creating a more optimized hydraulic system and improve the controllability, the valves, the friction in the pipes and those kind of things. But at the end, to create a more eco-efficient solution, it's all about changing the truck from combustion engine to an electric engine, so we don't need to run the combustion engine while we do our lifting job. So that's the key thing. So doing this means we also have to design a different interface, because if we have the high voltage power available on the truck, we need to link this to our hydraulic or to our classical lifting system. We need a new interface. Key is, and that's really the interesting question at the end, how will the availability of electricity at the end change the architecture of our lifting system in itself? Because today we are using hydraulics, we're using mechanical means to create this lifting job. If electricity is available, how would a crane look in the future which is designed completely different. But first, let's look at the interface between a truck and a lifting system or any other auxiliary, because it's very similar. You know, today, we have the situation today with a combustion engine. You have a classical mechanical power takeoff, and you connect a central hydraulic system by a direct mechanical connection, connecting the hydraulic pump directly to the PTO of the engine. Direct mechanical interface, of course, some data exchange, discrete or digital, and these are the type of applications you see everywhere. When we're now moving to an electric truck, we still have, of course, on one side our lifting system with the hydraulics. On the other side, we have now suddenly high power, high voltage DC electricity available. And what we need is an interface system between the two functions. So at the end, we need some kind of a system which is converting the electrical energy into mechanical energy so we can connect at the end our classical lifting system towards the electric truck. The key question is, who owns this interface system? And there are several versions and options available already. When we look at the solution, a very famous truck OEM, Volvo, is providing at the moment, they have integrated this interface, electrical interface system into the vehicle. So it's within the truck architecture, the electrical interface system is incorporated. And that's of course very advantage, or is a good solution for us as a lifting system supplier, because we can just link our system as it is, more or less without any changes, to the new electric truck. We can control it, quite simple installation. So this is what is available today. Second solution is that we're creating an independent system which is linked between the electrical truck and the lifting system or the hydraulic system of the lifting system. And this is what, for example, has been developed by ZF, the so-called eWorks module, which we have actually participated in this development, which is really creating an independent system we can connect in between the truck and our lifting system. And that, of course, helps us also to handle vehicles which only offer a high voltage supply interface by just putting something in between. And the third version of that is, of course, should we integrate this interface system to the lifting system? And that's really a question we need to ask ourselves, because at the end, if we really want to optimize the lifting system itself and answer the question how a lifting system can or crane will look like if we design it with the understanding of electricity in mind, how would a crane look like? Because if we look in other industries, industrial automation, 10 years, 15 years ago, you have seen pneumatic systems. Today, you see everywhere electrical drives. In our world, we see a lot of hydraulics, but now suddenly electricity is available. What kind of actuation is then at the end, the right one? And of course, there are, actuation functions where hydraulic is really key, and it's the only way to do it because you need high power, low weight, and those kind of conditions. But there are, of course, actuation jobs and actuation functions which could be turned into electricity or could be driven by electricity. So the key question is really, how will a crane look in the future if we design it with electricity in mind and with the availability of electricity? Then, of course, the question is, how can we, improve the effectiveness of the lifting operation. And here, we at PALFINGER are also pushing forward on increasing the productivity of our operators by introducing, assisting function and to really move towards an autonomous operation. So we have created a roadmap from, let's say, manual operated at level 0, and then all the way to full autonomous operation. And also here, it's really interesting to see how the availability of electricity and using electrical actuation not just is a more effective way to do, but also from a controllability and the use of sensor data and to be able to control also assisting or introduce assisting and autonomous function is actually supported by the electrification of the actuation. At the end, summarizing, we are moving forward with the 2 pillars, go for solution, go digital. But embedded in this is really moving to an eco-efficient solution, providing integrated, smart and eco-efficient lifting solution, which are really seamlessly integrated into the environment of our customer. So they are communicating with the environment. So we have to combine both pillars and the electrification into this strategy. The total energy consumption and the CO2 emission is mainly driven by the truck. So it is really the key to improve or change the truck and to really make an impact on the CO2 emission. So it is at the end, if we can take away the fear of our customer to that an electric crane vehicle is operating in the same way than a combustion engine driven crane vehicle, then we will have the biggest impact. So it's about how to seamlessly integrate the crane with the vehicle so that the operation is not changed and not affected, negatively affected, which at the end makes a big impact on the environment. It's not the 1 or 2% of efficiency we can take out of the hydraulic system of the crane. It's much more how easy it is for our customers to actually buy an electric-driven truck and use it in the same way as they do it today, which is really driving at the end the eco-efficiency of our solution. At the end, it's really important, saying all this, that the interface is designed the right way. So, with the different solutions between integrating it at the vehicle, having an independent system, or integrating it at the lifting system. And the key question, and I think the future will show this, is how the availability of electricity will change really actuation architecture in our industry on those lifting systems, and is a crane or it could also be any other construction machine, will change this. So I believe we will see really new ways of creating actuation also in our industry, moving away from this classical hydraulic system. With this, I'm ending, and thank you for your attention, and if you have any questions, thank you.
Yeah, your applause in the afternoon, and well,